All right, I'm excited to be here with you today. I think we're going to cover some really interesting topics that will be very helpful for folks, kind of let you in on a few of the behind the scenes secrets, I guess you could say, that hopefully will help your organization be able to manage your floor plans more efficiently, and just to spark some ideas on how this can be useful. So we're going to be looking specifically at, we're going to talk about some of the pain points that folks see in this area. We are also going to talk about a geospatial strategy, which I think will be helpful for those who aren't familiar with that term. We'll look at floor plan file organization, maybe some naming convention ideas, collecting data. If you don't have any floor plans, we're going to touch on that. We will also look at the process with collecting and turning those scanning, particularly SLAM scanning, and how you can turn that into usable floor plans in GIS. And then lastly, we'll cover some of those resources, SLAM scanning solutions. We have a slide for that, and also ArcGIS tools that are available to you specifically for indoor mapping and for floor plans in particular. So the pain points. So there's several pain points here that we come across very frequently as we talk with folks. Lack of access to organization, the updated floor plan information, just not having good access to it. People oftentimes have their files organized in their PDFs in a folder structure, but how do you easily access that as you engage with your building data and move from building to buildings and so on? So another one is data silos. Oftentimes the information is not available or it falls in different areas. And then the ability to share that information and distribute it across the organization, particularly with mapping and facility data, that can be a challenge if folks maybe they don't have AutoCAD installed on their desktop, things like that. This provides some good ideas and resources on how to share that. Another one is spending time just measuring, getting accurate space needs. Those are oftentimes things we hear challenges. And then a big one is just people having too many irons in the fire. They don't have time to worry about maps. We hear that, but for those that do make it a priority, I think that's important, and we'll see the benefits there. So the geospatial strategy, I want to spend a little time talking about this. This is a concept. You'll also hear this from Esri, and this is where I picked up this terminology. I think it's a great way to approach managing facilities, particularly the spatial components of those. So floor plans, 3D information, utilities, any GIS data or mapping data. Really, folks need to start with a geospatial strategy. So what is some of the key components? And this is not a completely inclusive list that I've got here, but the components of a geospatial strategy oftentimes will include these. The spatial requirements. So what coordinate system, accuracy requirements, data formats, those are all parts, including authoritative data sources. Where will that data live? So those are all requirements that should be included in a geospatial strategy. You want to document in your strategy, you want to have an idea on your enterprise environment. Is this going to be on-premise, going to be in the cloud, ArcGIS Online? Is there going to be a hybrid approach? How about architecture diagrams for that? Those are often helpful to diagram how I'm going to have my enterprise GIS set up and how I'm going to distribute that information and sharing strategies. The mapping, campus mapping data schema. So I do want to share that with you, just kind of get a glimpse here of a recent one that we worked with, the university example here, where we have mapping data. So, schema data. And here we have buildings, facilities, and we have all of this information broken down by address. And then, of course, using Esri's ArcGIS indoors information model, we map out where all this data is going. So we have CAD floor plans, but we wanted to point to where this information is going to go in the schema. And so that is a key part as we talk about this geospatial strategy. That is a key part of that, is being able to have a clear understanding of my mapping data schema that's going to be a part of that. Standard naming conventions as well. That's another area that is important as we talk about the geospatial strategy. How are my CAD files named? Is my GIS data going to be named? And also, how will I name web maps, web apps? All of that is important to consider as we think about the geospatial strategy. Timelines and stakeholders. So how long are these phases? What are my phases and my next steps? And how long am I projecting that to take? Where do I want to be in 2 years and 5 years? I often say the word strategy, when you see that, it means at least 1 year or more in a time frame. So that's just my own thinking is when I hear the word strategy, I'm thinking more than a year's time. So this could be, and as far as the key stakeholders, it could be different departments, different people individually, or even the public if I have information I'd like to share publicly. And then the data maintenance process, how I'm going to maintain my spatial data, you want that to definitely be a component of your geospatial strategy. Your strategy should answer questions such as what is the spatial accuracy of my exterior walls? We'll talk a little bit about that, what additional information is needed from CAD files. Maybe I don't have it in my CAD data. What else do I need? How about elevations? Is elevation going to be critical to me with my geospatial strategy? I would really answer that question as I would encourage you to answer it as yes. Elevations are important, and we're going to need to be thinking about how we're going to collect that data and how we're going to store it and how we're going to use it. Also, where will authoritative source data reside? Again, that's very important, and your geospatial strategy should answer that question. Who and what type of access will be needed, or how will that spatial data be updated after construction activities? Again, how does that workflow look? Very important to discuss and have those identified in your strategy. Okay, so let's talk about floor plan organization. This is really important as we think through this. So got this information from Penn State's OPP standards for their campus. They've got that online, a manual that talks about their file naming convention for their floor plans. And they break it down particularly with type and building and project and date. You can see all of these components that are a part of their file naming. This is a key component of organizing floor plan data, is having this information accessible, being able to index this information. So your building or facility ID is going to be a key component of your naming convention. Typically what we're seeing is clients are oftentimes organizing their data by facility. That's kind of the first kind of that major category. We're going to identify it by building or facilities. So definitely an important part of that naming convention. And then definitely being able to identify, how we're going to name these, and then how will my scanning data, how will I also name that and how will that affect my strategy and how I organize my floor plans. So this here slide talks a little bit more and breaks it down in more detail, talks about drawing type. So you can see the various types of floor plan drawings, as-built. We've got, different shop drawings that might be included with that. So it's important to specify what type of drawing is this that I want to reference for my floor plan information. And this can all be broken down in the naming designation. It can also be categorized as a domain in your GIS data. So very useful information here to have. Another one is discipline. I want to talk a little bit about this discipline category. This information was part of the National CAD Data Standards Level 1, and this is basically explaining the different disciplines. And for those who are familiar with CAD drawings, you are probably familiar already with this table, but you have these abbreviations and codes that can be used to categorize our type of plans that we're going to be referencing in that floor plan information. So many times you bring in CAD files or you reference them, you're going to see these abbreviations somewhere within that file name. So it's important to consider those. So however, what if my floor plans are outdated and even unusable? That is a very frequent occurrence. Even when I sometimes have a lot of confidence in my accuracy of my floor plan data, sometimes I find that it's just unusable. So if that's the case, never fear. We want to talk a little bit about how we would collect that data if we don't have it, or if it's not in a good state right now. So collecting that data, you've got options with drone mapping. Drones are going to be a really, really useful tool. We're hearing many campus facility departments taking advantage of drone technology, and that's really valuable for even for floor plans. We'll discuss a little bit more why. GPS data, that's obviously important as we reference ground control points. That's our standard process, as we would do collection and drone flights, and even scanning ground control points are critical in those processes. And then mobile collection, obviously being able to identify and update that information quickly from a mobile device. So the need for ground control, and here's a good example. I wanted to show this slide because I felt like it really gives a good picture of what goes on when we're trying to georeference CAD drawings. So in this example, let's say I bring in this CAD drawing, you can see, and the CAD is to scale. It looks nice. However, if I look at the underlying imagery, and this is just from Esri standard imagery that's available online, and I can see, I pull it in, and there's, obviously you have the roof line and the orthometric, differences that I can see here. It's not going to line up with my roof line. I want it to line up with my building footprint where it meets the ground. However, as you can see here, it's difficult to see in the aerial imagery. So if this is my only source of referencing where that facility goes and where I'm going to place my GIS layers for building that, I'm going to have some challenges with this. So some alternatives we can use to this is more accurate imagery, maybe collected by a drone, which is, should be georeferenced with ground control points or RTK level. Or I could look at some SLAM scanning, which we'll talk about that process. And what that'll do is it'll get my exterior walls at a point where they're accurate to within just a few inches. So, or even, maybe closer to 1 inch. By doing that, now I can really tightly georeference my CAD files, and my CAD drawings doing that. So let's talk about the process a little bit more. So what's the actual process of going from scan data to floor plans, and what does that look like? So the first step obviously is collecting that data. You walk through the building. In this case, we've got a GeoSlam here in the photo of collecting building information, just walking through. Again, it's using the SLAM technology, which is the mobile mapping technology. As you go, the scanner knows where it's at in reference to itself by using the data that it just collected as you walk through. So the steps are: extract that data from the scanning device. So after each scan, typically a scan might take you 15 to 20 minutes. If you get too much more than that, you might get too large of file sizes. You'll download the scan data. Usually it plugs in USB to a hard drive, and then you can download it there. Then typically the scanning, the system that you purchase will have some sort of software to unpack that raw scan data. And then, of course, you can match up in your georeferencing. You can match your ground control points if you use those to get your point cloud in a nice georeferenced environment, so you can take it and use it. And then we'll extract those georeferenced LAS files that we can use them in the GIS. So here's a screenshot. In our typical workflow, we use a open source software called Cloud Compare when it comes to being able to reference and look at sections of those floor plans. Some of you may be familiar with that. It's a pretty popular software. We've had good experience with that. We will use that to, number one, verify that our point clouds look good. You can toggle and view in 3D. And then the other really powerful thing that we use this for is cutting sections through those scans. So in order to get our floor plan data, we're going to cut sections, and there's a really useful tool in Cloud Compare. First of all, when you bring your scan data in, it's going to ask you if it's going to warn you about a global shift, because if it's georeferenced, especially if you're using state plane coordinates, then obviously those coordinates have a large, several digits are part of those. It's going to say, hey, do you want to shift all this data to make it easier to manipulate so you don't have so many digits in there? And Cloud Compare will warn you, and it'll allow you to preserve that global shift. But there is a cross-section tool within the software that allows you to specify how thick you want your sections to be. And typically I'll use about a 3-foot slice, and it'll cut the whole thing along the axis that you specify in those slices. So typically we're looking at the Z-axis, slicing them along there typically we'll do like a 3-foot or a 1-meter slice. And what that does is then it's very useful, very helpful when it comes to actually digitizing the floor plans. So in this example here, we're digitizing the floor plans. We're getting useful information from the scan data. And I wanted to just show what that looks like in a little bit more detail here. If I pull this over and we'll zoom in a little bit. So this is just an extracted PDF from there, but you can see how in this case, the main walls have been digitized. And because I have the point cloud georeferenced and I have it sliced, now I have a nice view of what's going on. And this is everything colored here is from the scan data from the point cloud itself. So now I can begin to digitize anything that I want to pick up in that scan, whether that's furniture. In this case, this is a manufacturing facility, and I'm going to be picking up major equipment in this example. And I'm going to be digitizing that, and then I'll be able to use that within my GIS. So some really some useful ways to use the scans and be able to digitize that information. So here's some scanning solutions. If it's something you're interested in, you're looking at, definitely I would encourage you to explore these different options. So in this case, on the top left here, I have what's called the example is called the hover map. That's one where you can attach a GoPro on the bottom and it'll give you a real RGB point cloud coloration. This next one is called the Leica BLK to go. So you can see the bottom portion, you hold the hand down there, and this is similar to one of their terrestrial units as well. The next one, we have the GeoSlam. This is the GeoSlam Zeb Horizon. And these are very similar. All of these here, the scanning heads are similar. The next one is called the Carta Stencil Pro. And you can see that's more of a heavier unit. But you can see the imagery cameras there attached to the bottom. Faro Focus Swift. This one is mounted on a cart, but this is using the SLAM technology there. And then the last one here example is the Leica Pegasus unit, which is a little bit more robust. It's got the 2 scanning heads on there for collecting additional information. This one also has a GPS reference included as well. So all of these solutions you see here are SLAM based. They're in the mobile mapping family. However, they're going to be used primarily for indoor mapping. And all of these units are going to run between $50,000 and $100,000 to give you an idea on price. Now, what's important though is as we look at equipment, we tend to just focus on the hardware, but I want to warn you, don't forget about the software. Software is so important when it comes to post-processing. You want to make sure you understand what process is involved and what that software is, because a lot of times the software is a significant component of the price tag. So just something to keep in mind as you look at those. Okay, I wanted to touch on ArcGIS Tools. So the ArcGIS platform, desktop, online, enterprise, is a great resource to be able to use for organizing your floor plan information. It's a spatial engagement tool that is really, we're seeing as major campuses adopt the use of ArcGIS, we're seeing tremendous success and a lot of investment going into this from universities in particular and large campuses, because they see the value in managing their data across this type of a platform. the database environment and the integration that's available to folks, just to really definitely picking up a lot of steam here. And then also the ability to share that data and manage this spatial data and share it across the organization is really helpful. And you have Esri's technical support, you know, as a major global provider in what I call the 900-pound gorilla in the mapping and GIS technology. It's well supported from that aspect. So next we have ArcGIS Tools and floor plans in particular, looking at what's available. So we have ArcGIS Indoors is definitely a key component of this. So floor plan information, particularly with the ArcGIS Indoors solution, I wanted to just touch on the geoprocessing that's available. There's a geoprocessing tool called Load Floor Plans within the ArcGIS Indoors solution. And we've used this before, and it's really nice for mapping how you would bring your CAD data into your ArcGIS geodatabase environment, particularly in the indoors model. And there's plenty of tools and resources out there. There's some really good YouTube videos that Esri puts out that can cover how to use these tools in more detail. So next, I wanted to just show an example of the floor plan viewer. Let me pull this over. So here's a just a brief example here of a floor plan viewer tool and how we might be able to use this to reference our other floor plan information, CAD files, PDF files. So in this situation, I've got a filter where I can filter by my level there. And let's say, and this is very preliminary, it's kind of crude here, but to be able to show you an example of how you can identify, say, project data. So let's say for this particular building, let's say I've got a plan, and I'm gonna create that outer boundary of what that plan covers. And I'm going to snap to, I'm holding down the control key since I'm using ArcGIS Online in this situation. And we'll double click to finish that plan. And now I can see it automatically grabbed my site ID and facility ID and levels ID as well. But what I'm really interested in is how can I basically attach plans, or how can I see those? So I can use the attachment tool there. I've got attachments enabled that I can put that information. We'll just call this, we'll just name it number 2. And we know it's part of the level 1, and I can save that. And then what I can do is I look here is I can also have the ability to attach information there and attach plans within there. So I have the projects, and then I can also attach different plans. I could select my categories. Again, just kind of a really preliminary example of the things we could do using GIS and how we can reference those drawings there. Other ArcGIS tools, you've got the Space Planner, which is a really useful tool for reserving workspaces. You might hear the term hoteling, very common there and available through the ArcGIS Indoors solution. Routing and navigation is key, building out those route networks so you can have turn-by-turn capabilities within your facilities. They're also floor aware. That's a term you might hear often as we refer to the ArcGIS platform. Again, plenty of videos and resources online to explore more about that. Just recently, Esri split off their IPS, or indoor positioning. So there is a specific solution that Esri has, ArcGIS IPS, and that is specific to enabling being able to see the blue dot, so to speak, on your indoor maps using an indoor positioning system. So if you've got beacons set up or need to set those up within your organization and across your campus, you can be able to reference the blue dot using ArcGIS IPS. And we are at CloudPoint, we're pleased to be an indoors specialty partner with Esri and find a lot of benefit there and being able to work with them and be aligned with them there. So just kind of wrapping things up here, really the 3 main takeaways I wanted to go over here. are particularly, number one, the importance of having a geospatial strategy. Again, Esri is a great resource for this. They really are stressing this as well, how you want to make sure you put some thought into this up front before you dive into just, implementing the solutions. You want to think it through, kind of have it documented on what your plan is moving forward, and make sure you get all the stakeholders and key people involved that you're going to need to get buy-in from. So this process definitely takes time. It could take, I would say anywhere from 3 months to a year if it's done correctly. So just important to keep that geospatial strategy in the forefront of our minds. And then also another big point I wanted to bring out: no floor plans, or if you have poor floor plan data, if it's outdated, don't worry. It is very possible to do scanning, particularly SLAM scanning. That's going to be much faster. It's going to be more affordable. It's really not a huge, daunting process that some people might make it out to be. So lastly, just the ability to use GIS to manage and organize your floor plan data. When we talk about the latest and greatest solutions, GIS in general is that solution that you're going to want to use for managing that floor plan data. And just as far as what we have to offer folks, if they're interested, we do have some service packages. We have a campus feasibility study that we take a look holistically at your whole campus and look at, what is help you kind of define that geospatial strategy for your campus. Then we also have the facility audit. If you just want to look at one particular facility that you're concerned about, or you want to start with that is certainly something we can look at doing a facility audit. We've got kickstarts for ArcGIS Pro, another one specifically for indoors. If your team wants to implement the indoor solution internally, we can help work with you there. Also, if you need to stand up your enterprise platform specific to indoors, that's something else that our enterprise team can certainly help with. We do offer pilot projects up to a certain number of square feet. I believe it's 50,000 square feet, where we will work with you on a pilot project on a single floor to be able to deploy the indoor solution and give you the opportunity to test it and see if it's right for you. So definitely something that you might want to consider for your organization.